Certainly. Thank you.
Okay, thank you. Well, I'm not repeating yesterday's talk. So, yesterday was LMBs, and what I thought I really ought to do was continue on from that talk, even though it's not the workshop day. I still think, rather than change the level, it'd be more interesting to discuss all the peripheral things like the generation of local oscillators, high-stab local oscillators. So if it seems at a level that is too low, then I'm sorry, but there ought to be a few things, I think, that are of interest. LMBs have dominated everything I've done. I just found them so interesting. And even in the Cambridge Beacon, just to be awkward, you'll see that we have two Grundig LMBs in there, just for the sake of putting them in, really. But you can see, as I said yesterday, that I've really tried to do the easiest way of putting a 10G system together. And most of what I do, virtually all of what I do, is at 10G, simply because I don't want the clutter on the mass. I don't want to upset neighbours, and there seem to be plenty of people on. So today, hopefully, there'll be more things that relate to other bands. But I can't really remember what I put on the slide, so we'll have to see. Oh yes, components, that's right. Well, I've got hold of components. Well, I'm glad Thomas is here, because I just found that's a great site he has on eBay for 24G stuff. All of those sites I regularly look at if I don't regularly buy things from. I found using eBay not that easy when somebody tells me just a supplier's name. I just tend to put it in Google, and it tends to link me straight into an item, and then jump from there onto what other things are for sale. I do a lot of printed circuit boards. I do use, and I'm a firm believer in surface mount. And the top store is just awash with loads and loads and loads of surface mount, really good surface mount components. And I must say, most of the stuff I buy is from there. So if you ever want up-to-date mimics and capacitors, now the whole lot, and the stock is continuously changing. And the prices are really good, and also he doesn't cheat on postage or anything like that. He'll send the whole lot for just a small uplift. So I regularly use that one. As with the guy in Bury as well, who has a good a selection of things I occasionally dip into. And I have to put Power Joseph on the bottom because I hear that mentioned so many times that it just has to go on the list. I'm sorry for the ones I might have missed, but those are the ones I find I use. I was really pleased when I saw Thomas was on the list of people who are going to be here today. I thought I would just put one slide up on. I mean, this is one of 5 pages, I think it is, of MMICs. It's just staggering, really. The vast majority of them are up to date. So I assume what he gets is end of production reels, perhaps. And there's filters and all sorts. The best thing to do is just go and have a look on that site, really. And a couple of examples. They're the items I mentioned yesterday that you see on LMBs. Well, the first item is, just bog standard amplifiers that will give you plenty of gain, and 25 for $7. You can't really, that's not expensive. So that's really good. The bottom one I put in because, again, fairly cheap, good extended frequency range, and I think in the case of that one, plenty of output as well, 100 milliwatts easily. So it's just worth keeping your eye on his website just to see what he has. If you're struggling, as I said yesterday, if you're struggling with small lead pitches, then okay, you'll find the old T-Pack or cross-pack devices in there as well. Although yesterday I was saying about getting them off old LMBs. Then this is a repeat of yesterday, taking off items from old LNBs. They're everywhere. Go down to any tip and you can guarantee to find an LNB. And again, as I mentioned, the NEC appears on so many of them. And that particular one with the C1H code, you'll see in just about every LNB, or 50% of the LNBs you'll come across. So again, that's worth having. And by popular demand, funnily enough, of all the slides I did yesterday, this is the one that everybody said, "Oh, can you email me this slide?" So of course now I'm worried about whether the accuracy is that great. But as I mentioned yesterday, the FHX06LG, bottom left, second to left, I've seen that used in some of Sam's designs, so I know that one's right. But it's all there on eBay, all there on Google if you search for it. But I was surprised with the gas FETs. That took a lot more searching than all the other components that I was looking for did. I don't know why that is. If you're stripping components down from boards, then discrete semiconductors I find are quite easy to find out what they are, because the sites like this, which will translate a code into a device, and although the code is often used, 5-6 times over, just by looking at the package and the sort of board it's come off, you really get a good idea of what it's likely to be, and in most cases you very quickly identify what the device is. But I haven't found the same thing on ICs or the like, or the gas FETs. If anybody knows of good sites to find information on, I'd be very pleased. But there's several sites like that, but this is the one I tend to use. So that's on components. My history of getting on 3 centimetres, as you know, was via satellite LNBs. And the first surprise I had was I built a multiplier strip up with an ordinary crystal and then drove 50 miles down the road to hear the Chelmsford beacon and didn't hear it. And it took a lot of visits to realise that that crystal oscillator could shift 100 kilohertz quite easily. And I realised that that was never going to be a great deal of use if I wanted to monitor bands quite a bit. But it just gets so frustrating when you're not quite sure where you are. And the first thing I tried doing just seemed to work, and that was taking a 5 meg reference or a 10 meg reference and just multiplying it straight up. You end up having a big multiplier strip. I think the 5 meg, what's that up to a gig, or 10 megs up to a gig, is times 800 or something, to 3 centimetres rather, is about times 800. But the way you can get around that, as I have done on one of the receivers here, is some of the old multiplier PMR equipment. You'll find that 10 megs, or 20 megs anyway, and some of the other less stable items, 14.4 megs common frequency, you'll find you can multiply those on an old Philips 296, for instance, the mobile board, or the base station 496. There were a lot of those about. Put that straight in and tune it up the output to 480 megs. So you can actually short out a lot of those multiplier stages if you want to do something easily. And that's, while I'm saying that, that's why I ought to really show you. Sorry, I didn't give you a warning. I beg your pardon. That's all we did. I showed this yesterday. This was the first 10 milliwatt beacon we had in Cambridge, which Ofcom didn't know anything about. And you can see there's really nothing to that. That was a similar thing using, it was an FR5000, so another Philips base station, multiplier, up to 200 megs, and then multiplying with diodes. Well, I'll come on to that later. And then pipe gap filters and what have you. And that is, LNBs, not a great deal in there. I mean, anyone could do that fairly quickly. And that's worked really well. I'll move on from that because I know I've mentioned that further on in the slides. But that's what I've done all the way now, or all the way up till now. I have discovered recently that, as I showed yesterday, I have GB3CAM, the spur, sat at the back here. So the signals you're seeing, one on WinRAD via crystal control, one on SpectraView via an SDR14, which is just an unmodified LNB. And you can see there was some drift. It looks as though the PC is locked up fairly early on, so there was still some drift. And it's a real shame I now can't, because it's locked up, I can't actually show the note, or I'll put the speaker on. I'm not going to mess around with that. But I think most of you heard that yesterday, and the tone was remarkably good. So you knew if you could phase lock the puck free-running oscillator, that you get a workable system. And Brian, oh yes, here, has been talking to me earlier about work is done to injection lock an LNB. I'm really interested to hear more about that. You know that anybody who was on wideband years ago would probably tried that as well. But I was really interested to hear that you could get reliable lock, and it came back into lock when you switched off and switched on again. Now, that's the direction I'd like to go in. But I think if you're starting out on the band, doing something more complicated like a multiplier strip in the long term might be easier until, if a nice design came out like some of Sam's designs and that were repeatable, that would be good. And we know the SDR group are working on things like that with synthesizers. So a synthesizer might be quite useful. And you can see for anybody who wants to have a dabble on 3 centimetres, as I said yesterday, all there is an LNB on the end of that, moving again, sorry, an LNB on the end of the SDR14, and the output's coming out at 618 megs. And the interesting thing there is the SDR14 gives you a second input that allows you to go into the A to D converter direct without any filtering. So that means that you can do things like harmonic sampling. So although the reference frequency is on 66 megahertz, in fact, you can look at twice that, 3 times that, and so on, and look the same distance either side. And that's what I've done here. And I think they only claim it goes up to a couple hundred megs or so. But this works quite happily with a 618 meg output. So it doesn't take much, does it? There's a DC insert for the LNB. There is a bandpass filter as well in there. But that would give you a method of just seeing what's on the band, even what's on narrowband. It would certainly allow you to keep in touch with the beacons. And it does stabilise down. Give it half an hour, and that line is absolutely vertical, as I think as you saw yesterday. I'd better move on. I know I'm moving well away from the slides, because I've just forgotten totally what I put on there. Those are the 2 boards I mentioned. Anybody in PMR trade would recognise, I'll just move around, would recognise the FX496, and less people would recognise the old FR5000 series, but there weren't too many of those because a synthesised unit was developed fairly quickly afterwards. So I'm going back to my multiplications. If you want to use a reference frequency, then there's really no chance virtually that you're going to get, by multiplying it up, you're going to get to the IF you want. But if you're happy to do double conversion, it's just amazing how if you spend a few nights going through various multiplication ratios, you can end up with quite useful mixes. Which I'll come on to. But certainly, if you want to do direct conversion, or you want a beacon, like I did there, standard frequencies like 12.8 and 14.4, you can multiply straight up to 10368. They nearly all have control pins for the frequency, and you can, from my experience, you can usually move a couple of hundred kcs with that. It gives you a lot of option. And for a beacon, that doesn't bring you in the beacon part of the band, I know, but certainly it does for the sideband and CW end. So that's a useful approach. Now you might say that, well, the beacon I showed you there was very poor, very little in there in terms of selectivity, so what am I throwing out? In terms of spurious, Peter was talking about spurious yesterday. And so, with my limited test equipment, I can't do a scan in one go. But what I've done there is 0 to, 13 or 14 gigs, I think. And everything, if I remember, is 70 down, apart from one component. I don't know where that's come from. But I didn't have time to really check it. But it certainly shows multiplying up hasn't been a problem. And I'm not lacking selectivity in the multiplier stages. Because although Peter talked about hearing signals that were 70 dB down, that's hardly a crime. 70 dB down is a long way down. People are going to hear locally. But you're well within, let's say that was a 1 watt transmitter. The spurious that you can see, if I just move around, the spurious you can see fairly close to the 10 gig signal would fail most commercials, would fail all commercial specs, but not elsewhere, not at 1 watt, because that's a long way down. So I think that's quite encouraging for a fairly basic multiplier derived signal. I think the more interesting thing, as I say, was doing a dual conversion, and there's two multiplications, both using 10 megs or 5 megs if you like, that will give you a useful frequency. So I'll talk about the first one. You can readily multiply up to 9.6 gigs. 9.6 gigs tends to be, you can multiply up to that in several different ways, and you always end up getting to 9.6. It's quite good because it gives you a fairly high first IF, which you can get good image response from. And as I showed yesterday, and I'll put in again today, even the image filter on a satellite LNB with the first IF of that will give you 30 dB of image rejection. In fact, it'll give you more, because that's certainly a higher IF than I had before. But it is something to think about later on, is do I want to spend a lot of money on filtering? Do I have a good filter that's cost me nothing? Or if I'm starting from scratch, do I want to make something like a pipe cut filter? If you do, then you might want to choose a higher first IF just to make the task of filtering that much more easy. But you can say I got to 768, and then you easily find that you can generate 720 from the 10 meg reference as well. So mix those two together and you got 6 meters as an IF, and that's what I currently use on 10 gigs. Now that's what I used to use. That's this receiver here, and I put that up just to show that satellite LNB easily dominates all the positions in there. I also put that up because I was really pleased when I first found that using a PMR mobile, you end up with plenty of power. You have too much power. So if I come out at the pre-driver, it gives me 1 watt, say, at 480 megs. I thought, well, I wonder what I can get out of that. And I'd played with interdigital filters on PCB material. And I found I got really good shape factors out of those, and deep out-of-band specs. I thought, well, I know I'll need a really good multiplier dial, but I just put a 1M4, 148 in. And I was absolutely staggered on there that times 5, with half a watt, I was getting 0 dBm out without any real effort. And I hope in there I've got a view of the spectrum from that. The other bits of filtering I'm going to come on to, so I think I'll not concentrate on that slide. Availability of really high stab oscillators. One I should have said, those Raycol standards that you see in frequency counters and the like, just put it in context. I get, at 10 gigs, an accuracy of plus or minus 100 hertz with that. And it tends to stay at that point. So I'm not seeing a lot of drift, but I know my receiver drifts up to 100 hertz, which I think is pretty good, really, for a standalone receiver. You at least know that you're going to hear, anybody who's also on that channel. But availability is rather patchy. 2 or 3 years ago, you could pick those 5 meg references up at just about every rally you went to. But I notice now they've died away again. But counters, you can often pick up local counters very cheaply. People don't seem to want them. Anyway, Peter said that yesterday about counters. People just don't seem to want them. So that's a good route forward. But what you may have in your Spurs box are these 14.4 meg references or 12.8. But I've just put down there another set of multiplications that we've done for, hopefully, a narrowband 3 centimetre receiver for the Cambridge Club, which I have some boards here, so if Peter's going to follow me. Now, I was quite pleased with these because I thought I'd made a small job, but I've just seen Sam's 1296 receiver, which is about postage stamp size and makes these look enormous, so I'm not so sure. I think I'll come on to those later. What I tried to do there was to see, oh yes, you know what it's like with a club. You say, well, what IF do you want? And the first person says, I want 2 metres. And somebody said, well, 77s would be better. And then somebody says, well, I don't have any UHF. So it gives you a bit of a headache. And what I found was, with that 14.4 meg, you can do 1296. So you can do a 1296 a jump. So that gives you a nice image. It makes a nice IF to make the image frequency, the image response very easy. It also allows you to go down to 144. But actually, if you're prepared to do a triple conversion, you can go down to 28.4, I think. So it's, for a general purpose thing, it makes a nice ratio. Oh, and that's the block diagram of that one. And hopefully nobody wants 28.8. But you can see that you may as well put it on the board because the extra multipliers actually don't take up a lot of space. So that's something I've been working on, and because we've been doing the Cambridge Beacon recently, 18 months it's taken to get the Cambridge Beacon going, so everything stopped for 18 months. But I'm quite pleased with that. I know there's some very large multiplications. On the bottom there's a ×7, but those interdigital filters, if you just keep putting one after the other and just stop when you're fed up of, doing images on the PCB artwork, you just find that they give really good performance. Something that came up recently, when we were doing the beacon, that was sort of like a joint, the 10 gig beacon in Cambridge was a joint venture between the Cambridge Repeater Group, Cambridge and District Amateur Radio Club, and then to me. And we set that going, and one of my friends, G4BAO, if anybody knows John, said it would be great if we could do 24G. So he said, I'll build that. So he did. But I've nothing to receive on there, and I thought, well, I at least need a converter. One of the things that Thomas was selling, but not at the moment, were these really good, they weren't Alcatel, were they? There were front-end blocks for 24G. Can you remember, Sam, what they were? Were they Alcatel with the quad? Yeah, okay. They're good. They were good mixers. I think they must have had an RF amp in front as well, all integrated in one. And they only wanted, like so many of those, half local oscillator frequency. And as I said yesterday, that gave a real good chance to use satellite LNB image filter as the last multiplier. But you also get nice ratios again from a 10 meg standard. So it's just amazing how we're just messing around with the figures and multiplications. You can make an integer number actually get to the IF you want. I showed these yesterday, but I thought it was worthwhile putting them on again today for people who weren't here. This shows the response of an old LNB from the days of single band, where we didn't have the high and low band. And you see that it doesn't actually cover 10G. And so if you wanted to use that on a satellite, on a 10G front end, you'd need to dielectrically load or bring down that filter. But that in its unmodified form was quite good for the 24G multiplier, because I wanted 11.52, and that's right in the middle of that. I also mentioned yesterday that this business of the image filter on the satellite LNB, if you use any modern LNB of the vintage that has 2 oscillator frequencies, in the UK anyway, you'll find that because the low band has moved down a few hundred megahertz as well, that image filter in nearly all cases will cover. Well, I haven't found a single LNB that doesn't remain flat at on the 10 gigameter band. It's right on the corner, but it works quite well. I also, and actually that's this Cambridge LNB is one of those dual band ones. And I show this just to show that that filter will give you quite a good image performance. This was when used on transmit. These modules have a diode mixer, so you can either step down, up convert or down convert. You use them on receive or transmit. So that graph applies equally, and you can see at whatever spacing that was. Oh, it was near enough, 9.6G. Yeah. So that shows you on this receiver, for instance, where I used that Cambridge LNB modified one as the front end. So even without any pipe cut filters, you're getting 30 dB of image performance straight away for nothing, without any modification to the image filter. I mentioned on that beacon that I'd multiplied by, I've used them several times. On that beacon I'd multiplied by ×5, I think. This shows the same filter multiplying by ×6. I think there's all the information on there. That's on FR4 laminate. I've put in 1 watt at 200 megs, or near enough, as you see. Just use ordinary silicon diodes, and you can see the output spectrum. I'm what, 10, 20, 30, 40, 50, 60, nearly 70, and you can't see any of the multiples below ×6 or above. So I think that's a really powerful way of multiplying up. And because I've come on to microwave relatively late stage, I was totally unaware of the JVL waveguide multiplier. But in effect, it's a version of that, isn't it? It's a minor version of that. And I rather like this idea of trying to multiply up a large ratio if you can. And I haven't really found any disadvantages of that. But I'd be happy if somebody has any. You see the general response of the filter. One thing I find, I don't have any software for analysing these, and I've really found no reliable way of controlling the width of the filter response. It's far wider than it need be. I've tried spacing out the lines. It doesn't seem to make a lot of difference. And that's why, in desperation, I did look at the Microwave Office website, you know, for professional software. But when I saw the price, I quickly decided that I would remain ignorant. And I've just carried on doing that. Using FR4 board means that there's some debate as to how repeatable a design is. I know that, because I think we all know that FR4 made for one firm will tend to behave in a reasonably well-defined way up into gigahertz. But you start buying from different sources and your artwork suddenly doesn't work on the next one. So I was lucky enough to get hold of some Taconic RF-35, which is 10, 20 gig dielectric, and specified dielectric. And on the beacon, my 10G beacon, I've used multipliers in the same way, and I just do a board. I just guess at what the sizing of the leg should be, and then just see what it does. And you could see this one I wanted 3.4G, and I was way down at below 3G, so I just altered my. But you can see how sharp it is, by the way, on the response. So I just redimensioned it, and till I got the right size. And on the beacon, in that module, I actually have two multipliers put together that is actually ×2 and ×2. And the one on the right is the one that you saw the picture of. For the slides, I thought it would be great if I showed the spectrum of that. But I realised I didn't have a generator to go in at 860 megs, and I couldn't use the rest of the beacon for reasons we don't need to go into. So I put my 8640 in, and that will only go up to just over 500 megs. And I found that at 432 going in there, I still got a lovely response. And again, you can see even using that first stage as ×4, the components are really well down. And that is a really reproducible way of getting a multiplier. And using, the other thing I do as well is I never seem to have a problem just driving an MMIC into clipping and then filtering what comes off the output. And I've done ×5, ×6, ×7 that way, and still got sort of 0 dBm out, or -10 dBm, say, out, so that's quite good. I'm always on the lookout for filters that match the multiplication ratios that I've done. And although the 897 meg one isn't very useful, you will find a lot that are on 947, 945, and they're usually 30, 40, 50 megs wide. And they are very good. And these dielectric resonators, you can see that they're quarter wave sections. It's a bit of a giveaway. They're usually larger than the small cell phone handset filters. But they're a bit of a giveaway here as to what they are. These are just quarter wave section, one end shorted off, metallized off, and then they couple in the other ends. But it's all screened off, so you never see that. Those give very good shape factors. So they're worth looking around. When you're looking around bits and pieces, they're really worth looking for and buying any boards that have those on, I find. Because that's a lot easier than, I mean, okay, etching a board is fine, but those 50 ohms in, 50 ohms out are very useful. Right, on filtering, go back to that. This is a long time ago. I wanted to just do some comparisons on filters. I'd made pipe cut filters they seemed incredibly easy to make. I'll talk about those in a minute. I thought, well, what about doing the job properly? And there were a couple of American designs for waveguide filters. And I found actually, just with hand tools, that you could pretty well get the performance that was being asked for. And you can see they are very sharp. If you insist on, if you really want a 144 meg IF, then you've pretty well got to put a good filter in there on transmit at least to save the image. But it's a good comparison of, yes, I'm sorry, I'm not telling you I'm moving. But you can see what you get. You pay your money and you get your choice. You can see that the pipe cap doesn't really live with those. But it's still giving you more than 30 dB image performance at a realistic distance away from 10G. So just for the sake of completeness, anybody who's looked through a lot of the American books, and as I understand it, these pipe cut filters first appeared in Dubus, but again, correct me if I'm wrong. they've appeared quite a lot. And you can see the general arrangement where you put a couple of probes into a cavity, and then you have a tuning screw that would just be quarter wave long. There's some debate as to what the cavity effect does, as to whether you get a resonance due to the cavity as well. But what I did with these was just to try one out. I thought, well, just keep moving the tuning screw down. I mean, just in case people have not seen those, do you want to put those round, and the dual one, which I'll come on to? And I found I could move down to nearly 6 centimetres. And the interesting thing was that the loss wasn't much different. And I was surprised about that. But I guess it's because on 3 centimetres the probes are at the bottom, but the tuning screw is right at the top. So there's, the coupling is much looser. But it shows you that if you're stuck for a filter, I mean, the obvious way of building with filters is to buy, if you see surplus filters, to use those. But if you're stuck, a pipe cut filter of some sort, or a resonator filter like that, is always a good backstop on any design. And the shape isn't that different either. So I thought, well, can I make them sharper, and what is the effect of putting 2 in series? Admittedly, on this, the coupling link between the 2 will have quite a big effect, because one's going to load the other, and what that reactance is with that length is going to make a big difference. And that was just an arbitrary length. And again, it would tune down to 6 centimetres, and you can start to see a bit of a change in shape factor. And also, you can see the rise again on the HF side. And that is definitely down to resonances that now involve the linking between the 2. And filters, if you've got 10 years to spare that you don't know what to do with, just playing around with filters is great. I mean, you look at any duplexer that you see, and you think, I know what's in this duplexer. And you'll always get a shock, because there's always little things you think, oh, they've done that deliberately. And, trying to work out why is interesting. And playing with these things, you're not expecting to see that response, and yet you do. So trying to work out why it's behaving like that is interesting. But it is in that coupling link, and if I half the length, you'd see a big change. I know you'd see a big change in that. Those quarter wave resonators are quite good above a few gigs, but coming down in frequency, and I was showing that first IF of 800 megs. What I've started to use, it's very wasteful on components, but I've started to use semi-rigid as filters. So again, it's just a quarter wave section with the open end fed into a trimmer so that you can change the resonance, and then coupled across to another one like that. So it's a top coupled pair basically, but I'm feeding in at the ground end. I find that a very useful all-purpose filter. I've absolutely no idea why that's now upside down. Let me just notice that. But the interesting thing with filters like this is the cold end. If you went into a quarter wave length of cable and the other end is open circuit, you're always told that input looks like a short circuit at resonance. And you think, well, that should be a good filter if I top couple. But you always find a very poor filter response. But you can, if you use the Q a bit better and you load down the input with a very low impedance and use the Q of the line to actually magnify that impedance up, you really sharpen up the response. Now the question is, do you use inductance or capacitance loading? And does it make any difference? And it does actually. So those are just examples of the... Oh, can I just send those around? That might be of interest. And again, you can see on one unit I can go from, what's that, 140 megs up to 350. So again, you're getting a 2 to 1 range. So good for odd frequencies. But going back to the end loading, I'm just showing the same slide again. Do you end load at the cold end with inductance or with shunt inductance or capacitance? And does it make a difference? Well, it really does, and intuition tells you it will. Because if you load with an inductance, you'd expect at DC you're going to get short circuit. So there should be more attenuation on the lower end than there is at the higher end. And likewise, you'd say the same thing with a capacitor. You'd think that at a high frequency end, the capacitor's going to look like a short. But I don't know whether that was chance, but that was a measurement I did, and that the one looks almost a mirror image of the other. And the interesting thing is, normally you see capacitive loading on all the designs I see. But what you actually want when you want an image filter and you're using low side injection is you actually want a sharper LO response. And you get that with shunt inductance. Just something to think about. Another thing to think about as well is when you want a shunt inductance of only a few ohms, if you try to use a capacitor, you know, capacitors, you talk about quality factor, and at such a low impedance, you like to run into problems of Q with a capacitor and what have you. But an inductor is just a piece of wire, as you'll see on those boards. So actually, inductive loading at the bottom is very cheap and very predictable. So that, I think, is the most useful slide of all of these. And of course, if you look at the top there, it's the classic thing where the more you couple in between the two tune circuits, the more you either get critical coupling and a really sharp point, or overcoupling and widening it out to what you actually want. And you can play with that to get what you want. But again, you can see you're getting a reasonable performance out of that. If it's not as much as you want, then again, you do what you do with any other tune circuit, put another section in, make it 3 sections, and that mid-section you just ground the cold end. And just keep throwing as many of those in as you need until you get as deep a response as you want. Right, moving away from LMBs. On the microwave bands, you need to know, one of the problems you have is how do you get a low inductance between the ground base, the common connection, the emitter or the source, and the rest of the PCB. And I don't know if this is what everybody else does, but what I found myself doing is just cutting a hole out for the device, but soldering in some copper, thin copper, onto the board, and then just bolting the device down. There's nothing very clever about that, but I'm mentioning it because I'm finding it quite hard to get power devices now. I have to look maybe a year on eBay before I ever see a 10 gig device. And they're usually quite expensive as well. So I started to look around at what current devices there are. Because we all know on 2.4G and cell phone frequencies, current devices are dirt cheap because they're used in such a big quantity. But they're surface mount, and you have to get the heat. That also means you have to get the heat through the board. And what I found is on 10G you can get 1 watt, 2 watt surface mount devices with gains of 20 dB at least for, I think I said £20, £25. That's better than what I've been paying on eBay. But the question is, how do you use them if you can't do plated through holes? And what I'm doing at the moment is attempting to use the same technique with maybe a packing piece of copper to bring that hole up to the level of the top and soldering devices on. But if you think the spacing on those MMICs is small, you want to look at some of the 10G power devices. They're a bit hard. This is an example of one I did at 1296. Surface mount device this time that did have leads coming out either side, so there's no difficulty in mounting it. But I use the method that you saw of soldering down to a copper plate soldered to the board. So that appears on my website and somewhere else, but I'm never quite sure where. What is interesting about this is the device was characterised really, or meant for use at 900 megs. But you can see from the data, like a lot of this LD master stuff, the frequency is usable much higher. I'll put this on because I think it's interesting. All I did was take the data sheet. Can I just send that round? And I just thought, well, what happens if I take the application note and just shorten the line lengths down by the same ratio for frequency difference, 1296 over 900, and do the same with the shunt capacitors. And the input works straight away. The output I messed around a bit with the trimmer, got a 2p2. But you can really see, you know, compared to where we were 10 years ago, 16 dB, it's a 28 volt device as well. I'm using this on 12 volts, 16 dB and 6 watts, just like that. It's just amazing. So it's worth looking at some of the amplifiers that when Kevin's got some there, you could do exactly the same thing with those devices. So power amplifiers on the lower microwave bands are becoming quite easy, but 10G, I just don't know where you get the devices from. That's the real downfall to the LMB route, is getting on transmitter anything more than 20 milliwatts, say. I've got to put this on because we've had conversations about this when we've been having coffee in Cambridge at dinner, when we meet up and have a bit. You remember the first early analogue days in the UK, once the silly squirrel type things had come and gone, and Sky was doing its thing, it was selling offset dishes that were oval. And you thought, well, that's okay, I understand these, it's obvious really. It's oval because when you view the dish from where the LMB sees it, you see a circle. So that's why I have to make it oval. I think that's reasonably obvious, isn't it? And then they brought these mini dishes out. And the trouble with that is that the ovalness, can't be right, is the other way. So my question is, why have they done that? Why have they made it oval in the wrong way to get equal resolution in vertical and horizontal? We think we have an answer, but I'd be interested if does anyone have a suggestion to make for that?
Well, if you've got a motorised dish, it doesn't have to be tracking properly.
If
you've got a motorised dish, it doesn't have to keep on tracking.
Well, I knew there'd be a wise guy somewhere sitting in there.
3 degrees apart, so you, by shaping the thing, they get a pattern that's not a single beam, so you cover 3 satellites. Because Astra isn't one satellite, it's a series.
Funnily enough, yeah.
It is, but the dishes are shaped. They're not. It's not for a single beam. You see. They fiddle with the shape.
Yeah, but that shape produces a sharper beam in the horizontal.
It doesn't in practice. It's much broader beam width on mine. I tried it.
It's a smaller dish, that's why, isn't it?
It's strange that Peter should say that, because we think, which means I haven't a clue, but other people I know have suggested, that almost the opposite of your reasoning applies. I'm pretty sure this is what it is. You need more east-west or horizontal resolution simply because the other satellites in Europe are only 3 or 4 degrees away. And so, in terms of signal to noise, from one satellite you can make the dish quite small. The trouble is you're obviously losing resolution, and you've now got the problem of interference from adjacent satellites. But I'd really like to know if anybody disagrees with that.
So the width of the dish is the same as the old Amstrad one? 67.
I know, I thought about that, but I think that's coincidence. Well, no, I wondered, that might or might not be
coincidence. Give you the horizontal resolution.
I think it is. I think it almost is.
The noise figure system has allowed it to be wider to allow less accuracy in terms of tracking around the plane.
Yeah. But I think that's the reason that that, you know, we just tend to think dishes will get smaller and smaller, but you forget that there's so many satellites up there that you're always going to need, you're likely to need resolution still to actually pick one out from the other. Right, well that's all I've done. That was really bitty, I'm sorry about that. Yesterday went well, and today I'd forgotten what the slides were, so I've gone backwards and forwards. I don't know if there's any questions though, I just have to rush